Hello, everyone. My name is Márton Braun. I'm a developer advocate at JetBrains, working on Kotlin Multiplatform, and related technologies. And today, I'm really happy and excited to talk to you about simplifying your build configurations with Emper. Emper is a new experimental build system that we are working on at JetBrains with the goal of simplifying the build setup experience and making the Kotlin ecosystem more approachable to developers of all backgrounds. We're trying to do this by creating a build system that is simple so that it gets out of your way and lets you work on the other parts of your project instead. A build system that's toolable, which will be largely achieved thanks to its declarative configuration files. And of course, a build system that is ready for multi-platform from day one. And there's really no better way of showcasing Emper than for you to just see it in action. So I'm going to hop over to a demo, which is going to be the majority of the talk. I have Fleet open here with an empty folder, which is where we're going to start from. You'll also see IntelliJ IDEA later on, where Emper is also supported. So starting from a completely empty folder, we can create our first Emper module file. And we are going to create a single module JVM application here for a start. As you can see, Fleet already offers me helpful templates that I can pick from. If I hop over here, I can also just pick other and write my own configuration from scratch. In this case, I want to create a JVM application. Now, I have to set up a build system to use with Emper, and there are two ways to set up Emper currently. You can configure Emper in a Gradle-based project, which is how we initially implemented, and as of yesterday, this is also available as a standalone build system. We'll see the Gradle-based version here first. If I choose that option, you can see that the project is populated with a Gradle wrapper. And if we take a look at the settings Gradle file, you can see that the Emper plugin was pulled in to support Emper in this project. From here, we can add some sources, which we again have intentions for. And in the source folder, let me just create a quick main function where we can print hello Emper real quick. And of course, I could run this like any other Kotlin main function from the gutter icon here. But if we have a look at, let me try that again. Let me fight that again with the touchpad here. So if we have a look at the Emper module file, we can see that whenever you define an application type in your Emper module, you also get tooling right there to run it, which is, of course, in a file that's really easy to find within your project because it's always in the same place. Now, this is a basic configuration here. Let's also add something more complicated. Let's say that we want to customize some settings. We have a settings block here inside our module configuration, which allows us to configure various tool chains. So here, you could configure things like Kotlin, JDK, Android-specific settings, and so on. For the sake of the example, let's take a look at Kotlin settings. And let's say that I want to configure the progressive mode of the compiler and turn that on. We can also use dependencies here. With a dependencies block. Let's say that I want to add Kotlin X datetime here for a demo. If I just type in part of the name of the dependency, you can see that we have completion support for dependencies here. And if I trigger completion again, I can also pick a stable version to work with. From here, I just re-import the Gradle project. And once that's done, the dependency will be available. One of the advantages of running Emper on top of Gradle is that you do have interop with Gradle here. So if I wanted to, I could have a build Gradle KTS file next to my module configuration and supplement my Emper configuration with that. And this can also help you introduce Emper into an existing Gradle-based project because you can mix and match modules within a single project. OK, so our sync has completed fairly quickly here. So let's just check that we actually imported that dependency. We can see that that clock is now available. And with a bit of AI assistant help, we can write this complex main function here, which prints the current time. So that's a very basic JVM application in a single module. As you can see, the basic setup here, before we started configuring things, just to run an application, was a single line of code with Emper. Let's hop over to a more complex project. This is, again, Gradle-based Emper still, again in Fleet. And we are going to take a look at a Kotlin Multiplatform project this time. In this project, we have a shared module, which is a multi-platform library. It contains data fetching as well as a UI implementation written in Compose Multiplatform. And we have a couple different applications like this Android app and iOS app here, which build on top of this shared module into actual applications for those platforms. If we take a look at the structure of the shared module, we can see that Emperor operates with a very flat source set structure. We have the regular source and test folders, which are your common sources in a multi-platform module. And then we have these qualified sources, which are platform-specific sources. So, for example, if you have actual implementations that need platform-specific APIs, then those would go in there. We can also have a look at the module file of this shared module, which is going to be a bit more complex than what we previously had, but still quite easy to read and go through. So this time, instead of an application, our module type is a library, which other modules are going to depend on. We are in a multi-platform library here, so we have to list the platforms that we're using. Because all of this is declarative and we have a schema, adding something like a new platform is really easy because we have great completion for all of that. Then we have the settings block again, which we already know. In this case, this is used to enable Compose in this module. And we also use Kotlin X serialization, which we can enable in the same settings block. Something really nice we have here with the settings block is that you don't have to know the exact path for these pieces of configuration in here that you want to follow. Let's say that you want to customize the name of the iOS framework that will be generated from this module. For that, you could just type in name here under the settings block, and it would give you all the different options available that have something to do with name, even if they're not at the top level. So we have this kind of nested completion where I could just autocomplete several levels at the same time and name something based on that. Okay, moving on, we have a dependencies block. Again, the regular dependencies block with a multi-platform module is going to be your common dependencies. And later down the file, you can see that we have these qualified dependency blocks for platform-specific dependencies as well. Then up here in the dependencies block, we have a couple entries from the built-in Compose version catalog in Emperor. These make it easy to grab those basic Compose multi-platform dependencies like foundation, material, and so on. We also have some entries here with the libs prefix, which are referencing entries from a Gradle version catalog, because we have interop with those catalogs. And of course, we can navigate to those and also navigate back through usages. Let's say that I've just realized that I want to add the content negotiation dependency for Ktor here. We, of course, have autocompletion here. As I start typing away libs, we can see all of the entries that are in there. And if I'm searching for content, I actually find out that I don't have that dependency in my catalog yet. So if we hop over to the catalog, we can see that it has actually been prepared. It was just commented out. So with this, we're simulating that we've just added a new line to the catalog. And as I come back and trigger completion again, that dependency will be available immediately without having to re-import the project or do anything like that, which is, again, possible because we have declarative files that we're working with here. Both the catalog file and the module configuration are fully declarative, so we can parse these and interpret changes in them in real time. You might also notice that I can freely search the entire path, the entire name of this catalog entry, so I don't have to know that it's called ktor.client.content. I can just search any part of it and get completion for it. We, of course, also have intentions for moving entries to the catalog automatically. And here you can see a really nice fleet feature, which gives you an exact line-by-line diff of what would change if you triggered a given action in there. So we can use that to move something to the catalog. Something I also want to show while we are here with the common and the platform-specific dependency blocks is that dependency search that's happening here with autocompletion is aware of which block you're working in. So let's say that I'm looking for the coil image loading library, and I want to add that as an Android dependency. Here, we'll see coil 3 showing up, which is the latest multi-platform ready version of the library. But if I scroll down, I will also see the older package of coil, which was the original Android library, both of which would, of course, work for the Android part of the app. But if I have a look at the same search under the multi-platform block, you'll see that I only get results for coil 3. So, of course, this search is aware of which library is multi-platform and which one isn't. One last thing I want to take a look at within this very same module is that you might also want to edit your configuration while you're actually editing your sources. A typical scenario for this is whenever you have something you're trying to opt into, where, of course, the IDE offers you a variety of different options for opting in at the declaration, the class, or the file level. But with Emper, you also get the option of opting in at the module level. For this, we need to add a compiler flag, essentially, to your configuration. But because we have a declarative configuration here with a schema that is well known, we can safely edit your configuration because there is only a single way to make this edit in there, and it's always an obvious way to do it. And with that, of course, the warning there is gone because we have opted in to use that annotation in the entire module. The last thing I want to show you within this project is the iOS application. The Android app looks pretty similar, so we'll look at the iOS one because it's a bit more interesting. Here, again, we are defining an application product. The iOS app, because it will want to reuse all of the things that we have written in the shared module, depends on that shared module, and it has compose enabled. And these 5 lines are the entire build setup for the iOS application here. We can also take a look at the source structure for the iOS app real quick. If we take a look here, we can see that the source folder contains both the Swift and Kotlin files required to bootstrap the iOS application, essentially to set up dependency injection and load the frame that compose content is going to go in. So with these 5 files, we have a working iOS application here. And we can, of course, actually build and run this. If we give that a moment, it should build it. It will start a simulator for us. And it should launch this app, which is also available in the KMP app template repository on the Emper branch. OK. With that, I want to move on to our last example project for today, which is going to be an IntelliJ IDEA, where we also have support for working with Emper. Here, I have a project which is using the standalone Emper build tool instead of a Gradle-based project. With this setup, Emper is handling almost all build tasks. So it's interpreting your configuration, it's resolving and downloading your dependencies, invoking compilers, running your application, and so on. In some cases, it does delegate to specific build tools and plugins. So it's still using the Android Gradle plugin for parts of Android builds and Xcode build invocations for iOS builds. But for example, if we take a look at this desktop application, which is the same sample as before, but for Compose Multiplatform on desktop, and we build and run this one, all of the build here will be handled by Emper from start to finish. As you can see, the invocation there on the build tab, which went away too quickly, is the Emper executable that we have right there in our project. Emper goes through that entire build, and it successfully started our desktop app for us. OK. So those are the demos for today. Here's a quick summary of the features. We've looked at most of these briefly. We didn't get to everything. For example, we didn't see that we can also, of course, test JVM and Kotlin Multiplatform projects. We also didn't have time to go into the Gradle interop features in Gradle-based Emper projects. And we only skimmed the surface of the tooling support in Fleet and IntelliJ IDEA. But as you can see, Emper can already build quite a lot with its current capabilities. We also have a lot of plans for the future. So the team is working on things like extensibility for Emper builds, for adding support for platform-specific tests, like Android instrumented tests, for packaging, publication, build variants, and more. So expect those to come in future updates. With that, I want to send you towards the Emper GitHub repository, which you can find at jb.gg/Emper, where you can find documentation, samples, and a lot of links and materials to get started and explore Emper. And at this stage, it's really important that we want to hear your feedback. We want to build Emper in a way where it fits your use cases and your real-life needs for your applications and projects. So please, once you've tried Emper, give us your feedback about it. A great place to go for this is the Emper channel on the Kotlin Lang Slack, where, again, you can quite easily get responses from the team directly. You can also file issues on UTrack. And, of course, please come and visit us at the JetBrains booth. We are going to be there after lunch today, as well as for a couple hours tomorrow. With that, thank you very much for your attention. Please don't forget to vote about how you like this session in the official Kotlin Conf app. And once again, see you at the booth. Thank you.